In this video, we are going to be taking a look at properties of two-dimensional figures. Now, the essential question that we are going to try to answer throughout the video is how can you use the strategy acted out? So that's what we're going to be taking a look at today, the acted out strategy, to approximate whether the sides of a figure are congruent. Now remember, congruent means same size, same shape, same everything. Okay, so exactly the same. So we are going to take a look at this essential question throughout today's video. Okay, so I want you to turn your books to page 453, and we're going to unlock this problem first of all. So the problem reads, Lori has a quadrilateral with vertices A, B, C, and D. Okay, you can see in the picture right over here and right in your book, A, B, C, and D. The quadrilateral has 4 right angles, which we can see. Okay, 4 right angles right where A, B, C, and D are labeled. She wants to show that quadrilateral ABCD is a square. Without a ruler, how can she show the quadrilateral has 4 congruent sides and is a square? Okay, so in order to figure this out, there's a couple things that we need to find out. Okay, so first of all, and I want you to fill this in on page 453, I need to determine whether the quadrilateral has 4 congruent sides. So we'll write congruent right here. And is a square. Okay, so it's always important whenever we're solving problem-solving type problems that we need to figure out what we need to find first of all, and that helps us zero in on the actual problem. Okay, so we can see some things that we can do to act it out here. Okay, you can even see on page 453. So something that you can do is trace a quadrilateral and cut it out. Okay, so you can use the acted out strategy by folding to match each pair of sides. So you can see that you can fold quadrilateral AB to side CD, okay, and so on. All right, so we can see that I folded the quadrilateral side AD to side BC, okay, right over here. And then also you can see that the quadrilateral can also be folded diagonally to match side AD to side AB and side CD to side BC. Okay, so those are some things that you can do to act it out if you're taking a look at a shape that you want to figure out if it's a square. If they all fold evenly, then we can start to realize that we are dealing with a square. Okay, so we'll answer this question. What else would you need to do in order to solve this problem? So you can continue to fold sides to match each other to make sure everything is congruent. So we still need to figure out that sides BC and AB are congruent and that sides CD and AD are congruent. And we can fold it along the other diagonal. So kind of doing the opposite of what we just did here. Okay, so whenever we fold it and we realize that every side is congruent, okay, we can come to the conclusion quadrilateral ABCD is a square. And keep in mind, this would be something that you would do if you did not have a ruler or if you did not have access to the measurements. Okay, so we're going to take a look at the problem on page 454. It says Terrence has drawn a triangle with vertices E, F, and G. The triangle has 3 congruent angles. He wants to show that triangle EFG has 3 congruent sides. Remember, this is something you do without a ruler. How can he show the triangle has 3 congruent sides? Okay, so we're going to answer these questions together on page 454. So first of all, what do I need to find? And let's write this out together. I need to determine whether sides EF, FG, and GE have the same length. I want you to write that right on page 454. So that's what we need to determine. Okay, now what information do I need to use? Let's jump on down to this question. Okay, we focused in on the question that we need to answer. So what information do I need to use? So the information I need to use is the figure is a triangle with 3 congruent angles. Okay, so the figure is a triangle with 3 congruent angles. Now you can see we're going to use the information just like we did with the previous problem. So I will trace the figure, cut it out, then act it out, and we're going to, by folding the figure to match all the sides to see if they are congruent. Now what I want you to do is trace this model on a separate sheet of paper, and then I do want you to cut it out and I want you to act it out. Now I do want you to draw each step or each fold that you do within your book, okay, right in that section where it says solve the problem. Then when you're finished with that, I do want you to explain this question here right in your book, and when you press play, I'll have the answer for you. Here's a possible explanation that you may have, and just take a look at your explanation, compare it to mine, and see how it matches up. It says, since 2 pairs of sides of the triangle are congruent, the third pair are congruent since they have related sides. For example, since EF is congruent to FG and EF is congruent to EG, sides FG and EG are congruent. So it's really important just to understand that since 2 pairs of sides of the triangle are congruent, that means the third are congruent as well, since they all have related sides. I want you to do the share and show question on page 455 all by yourself. When you press play, I will have the answer for you where it says finally answer the question. So you should have found that sides XY and XZ are congruent. I want you to solve this hot problem all by yourself by pressing pause, and when you press play, I will have the answer for you. Your answer should be 3 lines, and I do have the example of these 3 lines within this figure. And check and make sure your answer matches mine, and if it does not, let's see what you did wrong. Okay, I want you to do problems 7 and 8 all by yourself on page 456 by pressing pause, and when you press play, I will have the answers for you. Okay, here are the answers to these 2 problems. Check your answers and make sure they match with mine. Okay, finally here is the answer to our essential question. The essential question, first of all, was how can you use the strategy acted out to approximate whether the sides of a figure are congruent? And a possible answer could be, as we did throughout this video, is I can fold the figure as needed to decide if the sides are the same length. So that concludes our video of properties of 2-dimensional figures. It is important to make sure that you do act it out, and the way you act it out is by folding the figure that you're trying to figure out whether it's congruent or not. If you have any questions about this concept, please come and see me.